Hello everyone and welcome to another video. In this video we are going to do 4 questions which are based on HCF, LCM and of decimal expansion. That's for chapter 1, real number class 10th. In the first question it says a circular field has a circumference of 360 km. 3 cyclists start together and can run 48, 60 and 72 km a day around the field. Now question here is after how many days will they meet again? So this circular field whose circumference is how much? 360 kilometers. So this whole circumference is 360 kilometers. The first person is traveling 48 kilometers in one day. So if you are interested in finding out the time taken by the first person, let's say the person is A here, to complete one revolution, it should be what? 360 is to travel at the rate of 48 kilometer per day. So that will give you the answer in days. So let's multiply by 24 so as to get the answer in hours. So this is divisible by 2 times, 2 1 times, 2 180 times. So that comes out to be 180 hours. Now similarly, we can find the time taken by the second person. Let's say if I take B to complete one revolution, this would be 360, that divided by what? 60, because it is traveling 60 kilometer a day. But then we can multiply by 24 in order to get in hours. This is 6 times. So this is 24 into 6 number of hours, that is 144 hours. And similarly, the last part, the time taken by the third person, let's say if I take this as C, is going to be 360 kilometer, has to be covered at the rate of 72 kilometer per hour. But then we'll be multiplying by 24. So this is divisible by 72 5 times, and 5 into 24 is how much? 120. Now, once we got the time taken by each person, and then what we have to find out finally is the after how many days will they meet again. So we can see that the first person will come to this starting point in the multiples of 180, the others will become in the multiples of 140, and the third will come in the multiples of 120. So we have to find the common multiples, and to get the common multiples, clearly we'll be finding their LCM. So let's find their LCM, and we are going to use prime factorization in this case to find the LCM. So the first number here is what? 180. So this is 180. If I do prime factorization, this is by 2, 90 times, 2, 45 times, by 3, 15 times, 3, 5 times, and 5, 1 times. For the other number, that is how much it is? Other number is 144. So this is 272 times, 236 times, 218 times, 2 9 times, 3 3 times, and 3 1 time. We have one more number, and that is how much? That is 120. So same here also we are going to do prime factorization. This is 60 times, 230 times, 215 times, and then 3 5 times, 5 1 time. Now we are going to find the LCM, and if I write down the first number, that is 180, can be written as what? This is in their product of their prime, 2 square, 3 square, and 5. Similarly, for the other number, that is 144, can be written as what? This is 2 raised to the power 1, 2, 3, 4. 2 raised to the power 4 into 3 square. And lastly, it is 120, can be written as what? 2 raised to the power 3 into 3 multiplied by 5. Now to find the LCM, LCM is what? 2 with the highest power as 4, 2 raised to the power 4, and 3 with the highest power 2, that is 3 square, and 5 with the highest power as 1. So this is 2 raised to the power 4 is how much? 16. This is 9 and this is 5. So it's going to be 16 into 5 is 80, into 9 is 720 hours. So we can write this as 720 hours, or we may divide it by 24 to get the number of the answer in days. So this divided by Let me check it. This is 720 divided by 24 is how much? It is 30. Yes, so the final answer will be 30 days, right? We are going to get the answer in days. So we have to find out after how many days, right? So how many days we can see the number of days here is 30 in this case. Three bells toll at an interval of 9, 12, and 15 minutes respectively. If they start tolling together, after what time will they next toll together? So the question here, these three bells toll at an interval of 9 minutes. That means the first bell will toll in the multiples of 9. That is after 9 minutes, after 18 minutes, after 27 minutes, and so on. And the second bell will toll at an interval of 12 minutes. That is 2, 12, 24, 36, and so on. Similarly, the third bell will toll at an interval or multiples of 15, that is 15, 30, 45, 60, and so on. So the question here is that at what time they will toll together the next time. So clearly it has to be what the common multiples of 9, 12, and 15. So therefore we are going to find the LCM of these three numbers. So the lowest common multiple for this is what? 9 can be written as 3 square. If I write 12, 12 prime factorization is what? 2 square, that is 4 into 3. And the 15 prime factorization should be 3 into 5. Now for finding the LCM in this case, for finding the LCM, you are going to take the highest power of the prime here. So 2 with the highest power 2, 3 with the highest power 2 again, and 5 with highest power as 1. So this is what? 4 into 9 into 5. 4 into 5 is 20. 20 into 9 is how much? 180. So after 180 minutes, they will toll together. So the correct answer in that case will be 180 minutes. Can two numbers have 15 as their HCF and 175 as their LCM? Give reasons. So this question is based on this property that LCM is what? A multiple of HCF, or we may say that HCF is a factor of LCM. So the question is, can two numbers have 15 as their HCF and 175 as their LCM? So what we are going to do is to check, is 175 divisible by 15 or not? So let's say if I divide 175 with 15. So 15 one times is 15, remainder is 2, and you can see that 15 one time is 15, and it is leaving remainder 10. So it is not divisible, right? So what you can see that the answer is no. First answer is no, and the reason for that, you should say that HCF has to be a factor of LCM, should be the reason in this case. The number 7 over 75 will have non-terminating decimal expansion, terminating decimal expansion, non-terminating, non-repeating decimal expansion, or terminating, non-repeating decimal expansion. This question is based on the fact that a number in the form of p by q is said to have a terminating decimal expansion if the prime factorization of q should be in the form of 2 raised to the power m multiplied by 5 raised to the power n, where m and n are non-negative integers. So by non-negative, it means it can be 0 or any other positive integers. So this is what the question over here. We have to find whether this number will have terminating decimal expansions, non-terminating recurring, and so on. Well, the idea remains the same here, is to, first of all, I need to see whether these are co-prime or not. P and Q must be co-prime so that they do not have any common factor between them. And then I'm going to find the prime factorization of the denominator. So we know I can write this as what? 3 into what? 3 into 25. Further, I can write this as 5 into 5. So check here, 75, which is Q, right? The here 75 is the denominator, that is Q here. And it is in the form of 3 into 5 raised to the power 2. Now, once again, check it. Is it in the form of this, that is 2 raised to the power m into 5 raised to the power n? No, as it has factors other than 2 and 5, so it will be non-terminating recurring. So let me look into the factor non-terminating, repeating. Yeah, recurring or repeating is same. So correct option is this, that is non-terminating, repeating decimal expansion. And the reason, if you are asked to write down in some other question, you will say that the prime factorization of Q has factors other than 2 and 5. Therefore, it should be non-terminating recurring.